Hello everybody. Today we will play a game of revision, a revision of what we have taken this week. So, let's start. Now, in the sense of population growth pattern, okay, let's fill this map, or at least let's try to fill this map. Population growth patterns, we will fill these empty boxes with these words accordingly, okay? Population growth patterns are predictable based on ecological factors that availability of resources and are called these. So let's start here. So population growth patterns are predictable based on ecological factors that affect the or are and this. Now, ecological factors that affect the what? Affect, let's try carrying capacity, okay? So, predictable based on ecological factors that affect the carrying capacity that are what, that are population or logistic growth limiting factor. Let's try this, population. Now, factors that affect population size including birth, death, immigration, emigration. So immigration is the movement of individuals into what? So into a population. So we'll see what we are going to here. Now, the availability of resources and are called what? Limiting factor when resources are limited. Exponential growth or what? Help me guys, come on, think. So, the availability of resources and are called what? Limiting factor when the resources are limited. Exponential growth when resources are abundant. So, ecological factors that affect the carrying capacity are logistic growth. I don't know, let's see. Check. Oh, we are answering wrong answers. So let's try again. The limiting factor here, the logistic growth here, check. Wow, let's read the map together. So population growth patterns are predictable based on ecological factors that affect the carrying capacity that are a limiting factor. Factors that affect population size includes immigration, death, birth. Immigration is the movement of individuals into a population. The availability of resources are called exponential growth when resources are abundant. That's correct. Logistic growth when resources are limited. Okay, let's try another one. For the ecological succession. Okay, ecological succession often follows a what? Follows a what? Community, species, secondary succession, primary succession, pioneer species, ecosystem disturbance. Let's try ecosystem disturbance. Now, a sequence of changes called the ecological succession, a sequence of changes that called what? Let's see it again. It's secondary succession Primary succession. In a previously uninhabited area that is first inhabited by pioneer species. So, is a process of change in the what? In the community that make up a species. Is this correct, guys? Do you think? Let's see. Check. No. Here is actually the opposite. Is a process of change in the species that leads to a community. Okay? Don't forget, guys. These are tricky, may seem a tricky questions, like tricks, but it's easy. All you have to do is read the book properly and the study guide I provided you with. Okay? So, let's read this map together. Ecological succession often follows an ecosystem disturbance, a disaster like volcano. So, the ecological succession is a sequence of changes called primary succession because in a previously uninhabited area that is first inhabited by pioneer species leads to secondary succession in a damaged ecosystem. Do you remember, like a fire in a forest and the recovery of the forest? This is the recovery process is a secondary succession. Now, a process of change in the species that make up the community. Okay, let's try a new one. How do fires help succession? Fires return nutrients to the soil. Fires help break up rock to form soil. Fires destroy pioneer species and allow trees to grow. Fires help seeds to germinate. So, what do you think, guys? Which one? I'll give you 5 seconds. Okay. What do you say? A? Let's try A. It's correct. Next question. How does secondary succession differ from primary succession? Secondary succession has a definite end. Soil does not have to be replaced in primary succession. Soil does not have to be replaced in secondary succession. Pioneer species are not needed in primary succession. 5 seconds. Do I hear C? Okay, correct. Good job. What do pioneer species do? They break down solid rocks to form soil. They produce seeds that repopulate the area. They provide a habitat for small animals. They provide shade for animals. So, what do you think pioneer species do? 5 seconds. Do I hear B? Let's try. Oh, try again. C? Let's try. No. A? Correct. They break down solid rocks to form soil. Next question. Why does primary succession take longer than secondary succession? Because many fires must add nutrients to the soil before primary succession can take place. An ecosystem must be established in previously uninhabited area. A thick layer of soil must be formed so pioneer species can grow. Animals do not contribute to secondary succession. 5 seconds. Do I hear B? Correct. The last one. Which sequence is typical of primary succession? Lichens or lichens, according to your accent, British or American. So, lichens, shrubs, small trees, forest. Lichens, small trees, shrubs, pine forests, crabgrass, shrubs, small, crabgrass, mosses, oak, etc., etc. Oh, I'm hearing A. Correct. Nice job, guys. Next one. Okay, carrying capacity. What do you think carrying capacity means? Correct. It's number of individuals in that the resources of an environment can normally and persistently support. Commensalism. Right, ecological relationship in which one species receives a benefit but the other species is not affected, one way or another. Competition. Ecological relationship in which two organisms attempt to obtain the same resources. Correct. The next one, competitive exclusion. Let's see. Theory that states that no two species can occupy the same niche at the same time. Right. Next one. Density dependent limiting factor. Do you remember it, guys? Density dependent, not independent. Let's see. Environmental resistance that affects a population that has become overly crowded. Exactly. Because of the density of the population. Density independent limiting factor. While this environmental resistance that affects a population regardless of population density. Well, very good job, guys. You're doing well. Ecological equivalence. Organisms that share a similar niche but live in different geographical regions. Good. Correct. Ecological niche. All of the physical, chemical, and biological factors that a species needs to survive, stay healthy, and reproduce in an ecosystem. Good job. Next one. Emigration. You remember? Movement of individuals out of population, while immigration, the movement of population in to the new population. Exponential growth. What is exponential growth? A dramatic increase in population over a short period of time. Correct. Good job. Habitat. Combined biotic and abiotic factors found in the area where an organism lives. Good job. Next one. Immigration. We already explained immigration, guys. Do you remember? Now, thank you. I hope you had fun with today's session. We're done with our session today. Thank you very much, guys. Goodbye.